Okay, let's pick up where we left off the last time. You might be thinking to yourself, well, that's a pretty simple example, very easy to get. Let's see what we can do to screw this up, because mathematicians, math teachers are the kind of people who like to make things harder if we all possibly can, right? So let's try a couple of, well, these are actually still pretty simple examples, but let's work through them anyways. We have the expression 4a minus 5b minus 3a plus 2b, and the instructions are to simplify. What does that mean? Simplifying means that what we're going to do is we're going to combine any like terms that can be combined and get the simplest possible expression. So we look here, we've got two terms that contain a, two terms that contain b. If it helps, if you see these subtraction signs in between, we can rewrite this all in terms of addition and just use our properties of addition. So we're taking 4a plus negative 5b, if you want to think of it that way, plus negative 3a. Let me try to get my pen to work with me at least a little bit more nicely. Negative plus negative 3a. I have to remember to pick up my pen when I write. Plus 2b. Okay, now that we have that, we can say, well, in addition, it doesn't matter which order we put those numbers in, especially the two middle numbers, we can reverse their position and say, well, this is really the same thing as taking 4a plus negative 3a plus negative 5b plus 2b. Now we can combine our like terms. Of course, our like terms here are 4a and negative 3a. Well, that just becomes 1a. And negative 5b added to positive 2b is going to become negative 3b. In there. And 1a plus negative 3b, when simplified, well, we don't need to carry the 1, so we're just going to write that as a. Whenever we see a, we assume there's a variable of 1. Plus a negative is the same thing as subtracting 3b. This is the simplest form of this expression. Let's try it again right here. We've got y squared plus 2 plus 9y squared minus 14. Well, obviously, we're going to combine our like terms that contain y. So we've got two of them, y squared and 9y squared. We see that these variables also have matching exponents, which is a requirement for us to be able to add those like terms. So we're going to add y squared plus 9y squared. That's going to give us 10y squared. Then we're going to add 2 and negative 14, while 2 minus 14 is the same thing as saying minus 12. So this is our simplified expression. So hopefully you're thinking to yourself, well, that's pretty easy. What else could we possibly do? Well, let's try a few more. Right here, we're going to combine these terms. Well, we have negative 6 times negative 4y squared. And I'm going to justify what I do right here using my properties of algebra right here. We hadn't really quite done that, but we have our associative property of multiplication, which says when you take negative 6 times negative 4y squared, that's negative 4 times y squared. If you remember our rule that went a times b times c is the same thing as a times b times c. We can use our associative property of multiplication to justify the fact that we're going to take negative 6 and multiply it by negative 4, and that result would be multiplied by y squared. So by this rule, we're going to get positive 24y squared. Notice, by the way, we didn't have to multiply negative 6 times negative 4 and negative 6 times y squared, because negative 4 and y squared are already multiplied. We only have to use this associative rule right here. Let's try our associative rule again. This time we're going to take negative 1/9 times negative 9d. By our associative property, we know that means that we can take negative 1/9 and multiply that by negative 9. And that will be multiplied by d by this associative property. Now, one more property is at work right here. We note that we're taking negative 1/9 times 9. The negative times the negative will give us a positive, of course. 1/9 times 9 is the inverse property of multiplication, which, as you recall, said that if we take a number times its reciprocal, we always get 1. Well, that's what's going to happen right here. We're taking 1/9 times 9, so we're going to get 1 times d. But since 1 is never really shown as a coefficient, we just write d as the result here. Let's do one more, 5a times -6. Well, this should be pretty clear by now. We're going to be using our associative property. Once again, 5a times -6 is going to be the same thing as -30a.